Started it?
Yeah. Hello, everybody. Wait for you all to log on. It is now 12 o'clock. We'll get started when people start logging on. Sydney, have you had your lunch? How you doing, Worry? Well, you might want to get you some lunch. Sit it by you while we're talking. Oh, Isaiah, check this out. Just for you. Just for you. Well, get you something to eat. No, it's not nasty. Matter of fact, what's up? You see that trophy right there? Hold on, wait a minute. See that trophy? Well, I'm gonna get a few minutes for everybody to come on. And good morning. Good afternoon, everybody. You ain't eating breakfast. What? Go get you something to eat. Grab something to eat, Angela. Oh, well, when they hear me talking, that's why he's making noise. But he has a big, huge cage, so he's in there right now. He's eating, drinking water. He's good. If you don't stop. Oh, I'm sorry. Hey, how you doing? Okay, while I'm waiting, everybody went to the blog to see the homework. I worked it out. I put a little extra on there because we're going to talk about some of the extra stuff that I put in the homework. We're going to talk about that today. We're going to finish up binomial distributions and geometric distributions. So we'll be officially be done with chapter 6 today. All right, so what I'm going to do is I'm going to AP Central, and we're going to do some practice stuff. We're going to do some quizzes and tests on there for right now. But we're still going to do the practice test, the 3 practice tests that we normally do. So we'll work on start chapter 7 at the end of the week. And we'll finish up chapter 7 next week. Hopefully, we'll be back in 2 weeks, God willing. Then I want to be done with chapter 8 before next week, end of next week. No, the bird is not for you. Okay, so we only have 17 people, so we're going to go ahead and get started. All right, get you something to eat, get something to snack on. That's what I did before I came on. All right, now, so Marie, did you all get a chance to see problem 56 from the previous lesson, the B part? If you have any questions, we could talk about that first. Of course I am. We got to get through this first. One step at a time. Okay, so did you understand 56, the totality of 56, the B part as well, when they said the challenge? Oh, okay, good. So you said no, Danielle. So when we go over it, the B part of 56. All right, so I keep okay. All right, so we can do that. It'll only take a minute. Let me, where is problem 56? All right. So problem 56. So what we're doing is we're gonna do. So we got X. So we got our outcomes. It won't take but just a minute. We have our probabilities. So we got X is equal to, where is it? X equals 0 up to 4, right? So we got X equals 0, X is equal to 1, X is equal to 2, X is equal to 3, X is equal to 4. And so what do we have? So we had X. And then this we have for Y. Y was 0 to 3. Point 1, 2, 3. Okay, so that's 6.4. 1.2. 3. Both 0.3s. Okay, so that's 3. All right. So we're looking for everything where Y is greater than X. Okay. So remember these two functions, they're independent of each other. All right. So they're independent. So remember, if they're independent, you're going to multiply, right? So we're going to look at Y. So we got to see where Y is greater than X. So we're going to look at 1. So 1. So this is for Y. This is for X. So 1 here is greater than 0. Okay, but we got to find the probability for Y equals 1. So probably Y equals 1 is 0.3. Since they're independent, we got to multiply these two. And so for the probability of X equals 0, that's going to be 0.1. So that's going to give us 0.03. Then we got to come here. We got to do Y is 2. When Y is 2, we know Y is greater than 0. We know Y is greater than 1, right? So again, for 2, Y equals 2, we have 0.2. So Y is equal to 0. That's going to be 0.1. So then that's going to be 0.02. Then we have again, Y equals 2. That's 0.2. Then Y X equal to 1. That's going to be 0.2. So now we have 0.04. Now we got Y is equal to 3. Y is greater than 0. 3 is greater than 0. 3 is greater than 1. And 3 is greater than 2. So the probability for Y equals 3 is 0.1. Then the probability that X equals 0 is 0.1. So we have 0.01. Then now we have the probability, still got the probability of 3, which is for y. Probability y equals 3 is 0.1. Then you got the probability that x equals 1 is 0.2. Then now we got 0.02. Then now we got we know the probability of y equals 3 is 0.1. Then the probability that x is equal to 2 is 0.3. So that's going to be 0.03. And so that's going to be what? 5, 6, 10, 15. Carry 1. So when we did this we did the conditional outcome. So we didn't use the whole table. We just used a specific part of the table. So that made it conditional because we only want where we're only looking for we're trying to find a probability when y is strictly greater than x. So does it make sense now? Does it make sense so this is 56B. When they say it's a challenge, it's really is not a challenge. Okay, this is something we should know based on our probabilities. So we're not looking for the whole thing. We're only looking for a specific part of both tables combined. Kind of. Girl, if you don't stop. Okay, look. We're looking strictly looking for when y is greater than x. So you're gonna do, so we know that 0 equals 0, right? That's for y. But we know if y equals 1, the only thing that y is greater than on the table for x is 0. Now we're gonna look at 2. The only thing for y is equal to 2, we look at our x's, so we know that if y is equal to 2, we look at our x's, so it's going to be greater than 0, greater than 1. So these two tables are independent. So if they're independent, does probability rule from the previous chapters? So if they're independent, you're just going to multiply the each one of the outcomes, the probability of those outcomes occurring. So you would just simply do, if I'm looking at this one, I would do y equals 2, that's 0.2, times the probability of x equals 0. So I'm do 0.2 times 0.1. Now, again, I know that y is greater than y equals 2. 2 is greater than 0. 2 is greater than 1. Since they're independent, multiply. Then lastly, I have 3 is greater than 0. Possible combinations where y is greater than x. And so that probability of occurring